So last lesson we looked at polygons and the angles which were inside polygons. We said that, for example, one of these that's inside any polygon, I happen to have drawn a hexagon, but any polygon would do, and the angles on the inside are known as interior angles. As an example of an interior angle. But that begs the question, does there exist such a thing as an exterior angle? Is there one on the outside, like a similar idea? And there is, but before I show you what it actually is, I want to show you the common wrong answer. People very often think that, okay, well, if that's the interior, then that one on the outside must be the exterior. A very common answer, but that's not correct. So this one out here is not the exterior. Sure, it's on the outside, but it's not what we call the exterior angle. It is a slightly odd definition. I am going to go on to show you why it does actually make some sort of sense. But to begin with, you'll think, what on earth is going on here? So if the exterior angle is not there, where is it? What you need to do is take an edge and extend it. So for example, I might take this edge and extend this one in this direction. Like so. Notice how it's gone completely in the same direction as it was going before. It's just carried on in the same direction. What I haven't done is just sort of extended it any way I like made it a bit longer that way. It must carry on in the same direction. That there is an example of an exterior angle. Strange, right? So it's where you need to extend a line and then find the angle it makes with the next edge. I'll show you a few more. So here are the rest of the exterior angles you could have drawn on the picture. That's an exterior angle, that's an exterior angle, etc. The particular hexagon I've drawn here is not regular. The sides are different lengths. There's some symmetry to it, but it's not a regular hexagon. So you can't expect there to be any relationship between each of these angles. They're not necessarily the same or anything. However, if you add all 6 of them together, it comes to 360 degrees. That's actually a property of all polygons, no matter how many sides they have. So if you add up all 6 of the exterior angles of a hexagon, it's 360. But if you add up all 8 exterior angles of an octagon, it's 360. If you add up all 5 exterior angles of a pentagon, it's 360. So the sum of the exterior angles doesn't actually depend on the number of sides, which makes it a different rule to when we looked at interior angles, where if you had more sides, it adds up to more inside. I'd like to show you perhaps an application of this, because this is rather a strange definition. You might think, well, what's that got to do with anything? Okay, so this is an aerial view of the Pentagon building in the United States. It's where they keep their Homeland Defense. It's fairly famous in movies and things like that. This is like a view from a drone above it, or a satellite view maybe. What we'd like to do is pretend we're inside the building and there's a big corridor around the outside, and we'd like to do a walk around the outside. Okay, so nothing more complicated than we just go for a walk around the outside of the Pentagon building. Let's suppose the way you're going to do the walk is you will walk in straight lines. So, for example, you might do that part of the walk first. You started at the bottom, and then you walk up to the next point. And when you get to that point, you're going to turn on the spot. Now, my question is, how much do you need to turn? Okay, so you're going to walk along that bottom corridor first. You're going to turn right, so you're facing sort of approximately north. But what did you have to turn? How much did your body turn? And actually, if you think about it, that's how much your body turns. It's that angle in there. If you were facing in this direction here, you were facing that way. You'll then need to turn that much to be facing this direction. Okay, and in much the same way, you then need to turn and face that direction. If you're going to walk around the whole outside, you're going to keep turning, and you're doing this journey basically. Okay, and there's one more final turn to be facing back where you started again. I put that in red just to sort of say we've completed the journey. We've gone around the whole thing now, and we're facing back where we started again. All right. Because we went around the whole building, and we're now facing the direction we started, although we did it in 5 different steps, we must have turned a full turn. We must have gone through 360 degrees. So these 5 angles altogether were a full turn. You were facing in a certain direction, you walked around the whole building and you're facing the same direction again. So that must be 360 degrees. It feels like a slightly strange definition. Interior angles are so obvious. They're the ones on the inside of the polygon. And you think, well, why on earth would you have such a strange definition for exterior angles? Surely they're just the bits on the outside. No, exterior angles are these things where you extend an edge of the polygon and then connect it to the next edge of the polygon. Those there are the exterior angles. And in some ways, they're a lot easier than interior angles, because once you've drawn them on, they always add up to 360. And it doesn't matter how many sides the polygon actually has. It's 360 no matter what.